Hi, this is Tanya Drake, and the title of my final project is Graphs of Polar Functions. This is my lesson plan. All right, my math objectives are that students will develop a basic understanding of the polar coordinate system and locate points given in polar form. Students are going to convert points between polar and rectangular coordinates, and students will sketch graphs of polar equations. Our learning targets today will be 10th through 11th grade students in pre-calculus. We're going to classify different types of polar equations. We're going to explore patterns in graphs of polar curves, and they will predict the resulting graphical polar equation. The TEKS will be from section 3 under pre-calculus. It says the student uses the process of standards in mathematics to model and make connections between algebraic and geometric relations. And we only have to look at 3D and 3E. 3D says graph points in the polar coordinate system and convert between rectangular and polar coordinates. And 3E says to graph polar equations by plotting points and using technology. So the prior knowledge that we need here is that knowledge of X and Y coordinate system, our unit circle, and our trigonometric functions identities. The vocabulary, of course, will be polar coordinates, absolute value, pole, polar axis, rectangular coordinates, cordioid, rose petal, lemnicon. They will get a brief explanation of the polar system, of which I will go over in the lesson that we'll do today. So the engagement part will be that students are going to read their explanations and use simple polar functions and graphs. And students will practice graphing simple polar points and graphs. Next, our students will view a polar graph and try to determine its function based on information learned on the previous screens. Students will discover which parameters are used to create loops in a cardioid and the number and height of petals on a rose petal. And then they will get an explanation of the basic types of polar curves. And it'll go through all of that, and I'll go through that during the lesson as well. Finally, the evaluate part will be through the Desmos program that I will show you in a few seconds. The technology needed will be the laptop for Desmos and a graphing calculator. Materials needed, graph paper, pen, pencil, and then of course there's an assignment at the end using our on-ramps practice pages 6.1a and 6.1b. So now we go to the lesson, and this is our lesson, and I will put you in student preview. Okay, so the first thing you're going to see is this statement. It says, what are polar graphs? You've used rectangular coordinates and graphs up to this point, so what is a polar coordinate, or what are polar graphs? The polar coordinate system is a two-dimensional coordinate system defined by a point called the pole and a ray from the pole called the polar axis. In a rectangular coordinate system, the pole is usually placed at the origin, and the polar axis is represented by the positive x-axis. A point in the polar coordinate system is represented by the ordered pair, where the distance from the pole is the angle in radians measured counterclockwise from the polar axis. So this is what you're used to seeing, rectangular graphs in X and Y coordinate form. Now we go to polar graphs, which is our radius and our angle. So in the next screen, they will get the opportunity to see a graph. It says, this is the graph of a polar function, r equals 3. So looking at this graph, what does it look like? Of course, it looks like a circle, but how does this equation relate to what they see on this polar graph? And so hopefully they will see that there's a radius of 3 from the center. And then, of course, the rectangular equation, since it's from the center, should be x squared plus y squared equals the square root of 3 squared, or just 3. Next, we will have two circular graphs, but this time they are shifted to the right, and hopefully they will recognize that the red one is r equals cosine theta, and the blue one is r equals 4 cosine theta, noticing that 4 cosine theta has a diameter of 4 and cosine theta has a diameter of 1. And hopefully, just as the screen before, they should be able to write the rectangular equations for those two graphs. Next, we have the sine graphs. Hopefully, they'll notice that it is not on the x-axis, it is on the y-axis, and that this sine theta is 1 diameter and 5 sine theta is also a 5 diameter in the equations for those graphs are in rectangular form. So now that you've done that, what is the equation of this graph in polar form? And hopefully they will see that that is r equals 7. Right? Then, what is the polar equation of this graph? And since it's on this vertical axis, they should note to use the sine and then the diameter. So hopefully they'll be able to share that information down here under type math. All right, what is the polar equation for this graph? They should note that it is on the x-axis, centered around the x-axis, and it has a diameter of 5. So hopefully they will write the correct polar equation through this little button here. The next thing they will see is there is a point on the graph. So I've instructed them to click slider S so they can see what's happening with S. That was A. Here's S. Look at what's happening with S. And as you can see, I've only gotten it to go from -4 to 4, so you will be able to see it on the screen. Then click slider A. Now they can click A while that's going. It will be best for them to stop S and see what's happening. And so after they view all of that, hopefully they will be able to see that S cosine A and S sine A are the equivalent of your R and X and Y coordinates of points on the graph. Next, our students will be asked the question, how would you graph this a point on the polar graph that has a radius of 2 and an angle of pi over 3? Hopefully they will choose this one because it is the correct one, but we shall see. Next, our students will be asked to plot 2 points on the graph based off of what they learned on the previous screen. And hopefully they'll note that they need to use some sort of parentheses and some some number. I'm just going to do 2, 0. And then hopefully you can see the point there. All right, I'm going to take that off. Next, we have a popular polar graph. This is the functions graphed here are r equals 2 plus 2 cosine theta, 3 plus 3 cosine theta, where r is a function of theta. And notice the change when you add a number and multiply the polar equation by the same number. What's happening? What do these graphs look like? What's going to happen if you do 5 plus 5? What happens if you change the parameter, and this time instead of 2 plus 2 cosine theta, we have a 2 plus 4 cosine theta, or 3 plus 5. What do you notice? And hopefully they're going to notice that these graphs have a loop, not just a dimple, but a loop inside. All right. The next graph is for them to create their own chordioid with a loop in the center. And then this is the test to see if they know where to put the larger number to create the loop. Hopefully they know that the larger number should be B. All right. The rose petal graph, of course, is a sine graph. And we have a 5 sine, and then there's 2 theta. What does the 5 do? What does the 2 do? What does the 5 do, and what does the 3 do? So my question to them is, which is which? Which one is the blue graph? Which one is the red graph? And describe their differences. What part of the function makes them different? And we'll get an explanation from them. All right. Then next, create your own rose petal graph. Let's see if you know what to do. Then next we have an explanation of these types. So it says a rose curve resembles the petals of a rose flower, and it's in the form of A sine B theta. A cardioid resembles a heart-shaped curve traced by a point on the circumference of a circle as it rolls around another identical circle, A plus B. Now I'm going to explain this A plus B in a minute because it also appears here. Limacon is a roulette formed by the path of a point fixed to a circle when that circle rolls around the outside of a circle of equal radius. Now here's the difference between the two. When A is less than B, the graph is a limacon with an inner loop. When A is greater than B, the graph is a dimpled limacon. When A equals B, the graph is a special case of a limacon, and it's called a cardioid. Now, I didn't say anything about these rose petals, so I want them to answer that question. What's going to determine the number of petals on the rose curve? Is it A? Is it B? And so hopefully by now they know. Okay, so here's the fun part. They get to name what is this function, and there's 8 rose petals, but there's not an 8 here in the mix. So hopefully they're going to begin to understand that when you have an even number, that it's going to be a double amount of rose petals evenly across the top and the bottom, a reflection, if you will. Okay, then we have this fun looking graph, and it's a sine function, but I don't know if they will know this. What in the world is going on with this little tiny petal and this fat petal? So I want to see if they can figure it out just by playing around with Desmos on their calculator. Then write the function that creates this graph. And then, of course, we want to say what seems to be true when creating multiple petals. We could have extended this and asked about even number and odd number of petals, but I really wanted them to just stick with what I have on this lesson for now. Then I have a plethora of equations here. 1, 2, 3, 4 equations here. And some of them involve inequalities, the shading that you see. And so I would like for them to try to figure out if they can recreate this. What is happening? Why is this so fat? How come this doesn't go to the center? All right, so they're going to have to figure that out. And hopefully they'll note that this is a cosine graph that has a larger B value than the A. Then I have this fun looking graph. Here I multiplied sine theta and cosine theta. So I want them to try to determine the function of the graph, and I gave them some hints. You're going to have 3 parameters, A, B, and C. You're going to use sine or cosine here, and then some number there. Let's see if I can figure it out. And then lastly, write the functions of the graph, and you're going to have to combine 2 reciprocal functions. So we have, hopefully they'll know that our reciprocal functions are the cosecant and the secant graphs, and maybe they can figure it out. We'll see. So this is the fun part of just playing around with Desmos graphs. And then, of course, my last screen says, what have you learned about the graphs of polar functions? Write 3 things that you have learned about polar graphs, then complete the assignments in Google Classroom. And what they're going to see in Google Classroom will be this function, this page, and this page. And so that is my entire lesson. I hope you enjoyed it. Thank you, and have a great day.